Have you ever wondered how powerful an atomic bomb really is? It's a question that may have crossed your mind as you've watched a movie or read a history book. The answer, simply put, is incredibly powerful. But to truly grasp this power, we need to understand what an atomic bomb is and how it works. An atomic bomb is a weapon that releases energy through nuclear reactions, specifically nuclear fission or fusion. In nuclear fission, the nucleus of an atom is split into two smaller fragments, releasing a vast amount of energy in the process. This is the principle that powers the infamous atomic bombs like those dropped on Hiroshima and Nagasaki during the Second World War. On the other hand, nuclear fusion is a process where two light atomic nuclei combine to form a heavier nucleus. This is the same process that powers the sun and other stars in our universe. Fusion bombs, also known as hydrogen bombs, are many times more powerful than fission bombs, but they are also more complex and difficult to create. Now imagine all that energy, all that power contained in a single small device. That's the reality of an atomic bomb. It's a weapon of immense power and destructive potential, but it's not just about the raw power of these weapons. The true horror of atomic bombs lies in their aftermath, the radioactive fallout. This lingering radiation can contaminate large areas for many years, causing long-term damage to the environment and health risks for living beings. So an atomic bomb is not just a bomb, it's a device that harnesses the fundamental forces of the universe, turning them into a tool of destruction. It's a testament to the power of human ingenuity, but also a stark reminder of our capacity for destruction. So now that we understand what an atomic bomb is, let's delve into the history of its development. The birth of the atomic bomb was a result of the tension and fear that marked the Second World War. In this era of uncertainty and rapid scientific advancement, the United States embarked on a secret mission that would forever change the course of history, the Manhattan Project. This was not a small undertaking. The Manhattan Project was a massive clandestine operation that spanned several years, from 1942 to 1946. Its goal was clear and daunting: to develop a weapon of unprecedented power, an atomic bomb. At the helm of this colossal endeavor was Robert Oppenheimer, a brilliant physicist who took on the role of scientific director. Oppenheimer, known as the father of the atomic bomb, led a team of the world's brightest minds in a race against time. The fear was palpable. They believed they were in a competition with Nazi Germany, who they suspected was working on a similar project. One name that cannot be overlooked when discussing the Manhattan Project is Albert Einstein. Although not directly involved in the project, it was Einstein's letter to President Roosevelt in 1939 that sparked the initial interest in atomic energy as a military tool. Einstein warned of the devastating potential if Germany were to develop such a weapon first. This warning played a significant role in the US government's decision to launch the Manhattan Project. Together, these scientists and many others worked tirelessly, often in secret locations and under immense pressure. They faced countless challenges, both technical and ethical. The weight of what they were creating, a weapon capable of mass destruction on a scale never before seen, was not lost on them. The culmination of the Manhattan Project was the creation of two types of atomic bombs: the Little Boy, a uranium gun-type bomb, and the Fat Man, a plutonium implosion-type bomb. These two bombs marked the beginning of the nuclear age, showcasing the terrifying power humanity had harnessed. The world would never be the same again. The atomic bomb was no longer a theory, it was a reality. The world witnessed the destructive power of atomic bombs for the first time in 1945. It was in the final stages of World War II when the United States dropped two atomic bombs on the Japanese cities of Hiroshima and Nagasaki. These bombings marked the first, and to this date, the only uses of nuclear weapons in armed conflict. On the morning of August 6, 1945, the city of Hiroshima was obliterated by an atomic bomb named Little Boy. It exploded with an energy equivalent to approximately 15 kilotons of TNT, immediately killing an estimated 70,000 people. The city itself was reduced to ruins, with only a few concrete structures remaining amongst the devastation. Just 3 days later, on August 9th, another atomic bomb, known as Fat Man, was dropped on the city of Nagasaki. The bomb detonated with an energy of about 21 kilotons of TNT, instantly killing around 40,000 people. The city was left in ruins, with the vast majority of its buildings destroyed or severely damaged. But the immediate devastation was just the beginning. The bombings also left behind a horrifying legacy of long-term effects. Survivors, known as hibakusha, faced the horrors of radiation sickness, burns, and injuries. The radiation led to an increase in cancer and other illnesses, affecting survivors and their descendants for generations. Moreover, the bombings had a profound impact on the international community. They highlighted the catastrophic potential of nuclear weapons, leading to a global push for disarmament and non-proliferation. The bombings also marked the beginning of the nuclear age, shaping the dynamics of international relations and global politics in the decades that followed. The bombings of Hiroshima and Nagasaki demonstrated the devastating power of atomic bombs and changed the course of history. They serve as a stark reminder of the destructive potential of nuclear weapons, emphasizing the importance of prevention and the pursuit of a world free from the threat of nuclear warfare. As technology advanced, so did the power of atomic bombs. The mid-20th century saw a significant leap in atomic technology, leading to the development of a far more destructive weapon, the thermonuclear bomb, also known as the hydrogen bomb. This new breed of nuclear weaponry was not merely an upgrade, it was a complete game-changer. The hydrogen bomb derives its immense power from the fusion of isotopes of hydrogen, hence its name. This fusion process releases energy on a scale that dwarfs the fission process used in the bombs that devastated Hiroshima and Nagasaki. The science behind it is complex, but the result is straightforward: a bomb of incomparable power. A key event in the history of thermonuclear weapons was the testing of the Tsar Bomba by the Soviet Union. The Tsar Bomba, detonated in 1961, was the most powerful nuclear weapon ever tested. Its explosion was equivalent to 50 million tons of TNT. To put that in perspective, that's over 3,000 times more powerful than the bomb dropped on Hiroshima. It's worth noting that the Tsar Bomba was not a practical weapon. It was so large and heavy that it could not be delivered by any existing aircraft. Its purpose was primarily to demonstrate the Soviet Union's technological prowess during the height of the Cold War. The development of thermonuclear weapons was not without controversy. Many scientists and policymakers were deeply concerned about the potential for an arms race and the risk of nuclear war. These concerns continue to resonate today as nations grapple with the challenge of nuclear proliferation and the threat of nuclear terrorism. The power of the atomic bomb has increased dramatically since its inception. The first atomic bombs were measured in kilotons, equivalent to thousands of tons of TNT. Today's thermonuclear bombs are measured in megatons, equivalent to millions of tons of TNT. This exponential increase in power is a sobering reminder of the destructive potential that humanity has at its disposal. The development of thermonuclear bombs marked a new era of nuclear weaponry, with bombs that are thousands of times more powerful than those used in World War II. Today, the power of atomic bombs is beyond what most of us can even imagine. Atomic bombs have come a long way since their inception, and the level of destruction they can cause is truly mind-boggling. In the present day, there are approximately 9 countries worldwide known to possess nuclear weapons, with a combined arsenal estimated at nearly 14,000 warheads. It's a staggering figure, isn't it? And each of these warheads carries a destructive force exponentially greater than the bombs dropped on Hiroshima and Nagasaki. Let's put this into perspective. The bomb dropped on Hiroshima in 1945, nicknamed Little Boy, had a yield of about 15 kilotons. In contrast, the most powerful weapon currently in the United States arsenal, the B-83 bomb, has a yield of 1.2 megatons. That's 80 times more powerful than Little Boy. It's a sobering thought. The estimated total yield of all the nuclear weapons in the world combined is around 5,000 megatons. To put that in perspective, that's enough to wipe out the entire human population several times over. The destructive potential of these weapons is a testament to the terrifying heights that human technology has reached. And yet, despite their incredible destructive power, there's a certain paradox to nuclear weapons. They've arguably contributed to maintaining peace during the Cold War through the doctrine of mutually assured destruction. But at the same time, their existence continues to pose an existential threat to humanity. The power of atomic bombs today is a stark reminder of the destructive potential of human technology. It's a reminder of our capacity for creation and destruction, a testament to our technological prowess, and a warning of the dire consequences should we let this power fall into the wrong hands. It's a lesson we must never forget as we continue to navigate the complexities of the nuclear age.